Very well, welcome to this video where we're going to go over the representation of data via histograms. Histogram something that we're going to be dealing with in a minute, but first I want to focus on a very important thing that happens in some exercises of the A levels that we need to worry about, that this is rounding, okay? Um, think about it in these terms. Imagine that we are measuring height, for example, and our height is given to the nearest centimeter. Okay, um, this means, for example, that if someone has a height of 145.7, that would be rounded to 146. Okay, and then a height of 150.3 would be rounded to 100.50. Okay, so when we consider the classes of this exercise, we are told that the class goes, for example, of 145 from 146 up to 150, and then the remaining class goes from 151 up to 155. That makes sense, right? Because we're rounding, so you will either be in the 150 or the 151 class. The thing is here that there's a gap there, that if we are working with continuous data, because the thing here is we have continuous data, the thing is that we need to be careful about that, because we have a gap and we cannot have gaps with continuous data. So the actual classes, the ones that we are actually working with the data, are going to be redefined considering this rounding. So actually the class that goes from 146 up to 150 begins at 145 and a half, because that's the smallest value where that if you round it, you get inside the class of 146, right? And then the highest value is not going to be 150, because you can have values inside that interval that are greater than 150. It could be 150.1 or 0.2 or 0.3 or 0.5 or 0.5 or 0.59. It could be like really close to 150 and a half. We're going to assume here that, okay, we're going to take like 150 and a half with the beginning of this next class, because that value would be rounded to 151. So it's going to be our actual boundary to be 150 and a half. And then we can keep on going. And so we would be redefining our classes to be different than they actually are. This is something that we need to consider whenever we are told that data is rounded. If data is rounded, we need to consider the actual classes versus the given classes. And then the other things going to change are going to be the class-mid values, because the class-mid values are going to be given by this difference that may have some changes. In this case, for example, it's not going to be different, but in some cases it may vary a little depending on how things work. So before we address this, consider continuous data to be rounded. In some cases, if the task tells you that data is rounding, or if you see gaps with continuous data, you need to worry about this. In some cases, it's not going to be necessary. So now, yes, let's go to the histogram and how the histograms work. So we're going to see that histogram is going to be used essentially when working with continuous data. And in this case, we are given age against the number of students. Okay, so we have students from 16 to 18, from 18 up to 20 not included, and from 20 up to 22 not including. Observe two things. Things number one is that there are no gaps. It's like you're either 18 or you haven't turned 18 yet, so you're either one. So in this case, we don't have this rounding problem. And then observe that all of the classes have equal width. That is something that's going to be important when addressing histograms. So how is this going to work? This is going to be like very easy. It's just we're going to plug a horizontal axis that's going to show the age, and a vertical axis that's going to show the frequency, and it's going to look something like this. We have the age here, 16, 17, 18, 19, 20, 21, 22, and then we have the frequency 10, 20, 30, 40, 50, and this beautiful histogram. I want to focus in the histogram on two very important things. The first one is that there, as I told you earlier, in continuous data, there is no gap. So as there is no gap with the data, there is no gap within the var. Note that here the two bars, the bar from 16 to 18 and 18 to 20, are close together, they're stick together. That is something that histograms do have. Histograms have data that is going to be stuck like that to show that data is continuous. Okay, if we were to show a gap there, then data would not be continuous. So the idea of the histogram when continuous data is that you have to show continuous data. And then I want to focus on a very particular thing that I don't know if you know, that is over here. Let me zoom in a bit and let me try to show you here this beautiful thing that we have here. This is called the cortina of the axis, and this is just to show that data has been that some values in the axis have been omitted. Okay, they have been omitted because it would have made no sense for me to just go and show data like from 0 to 16 and having everything blank. Okay, remember that in the exam you will have to do your diagrams in the most suitable way visually, right? It's like if you're given a space like this, for example, you need to use as much space as you can, having everything enter to where you need to enter. So, for example, if you were to draw this from 0 to 22, you would have like 3/4 of the diagram to be all white or blank, and you don't want that. So we use this to note that some values are omitted because we don't want them to, we don't use them. So as we don't use them, we omit them with this with cortina of the axis. Okay, so you need to make good use of it so as it's not a problem. Now, this so far has been easy because we have classes that have equal width. 2 years, 2 years, and 2 years. Now, what happens when we have data that has not equal width? Well, we need to observe that the areas of each of the bars are proportional to the frequency. This is something that always happens when working with a histogram and always must, and it must always happen. So when we don't have equal width, we still need to fulfill this. Thus, we're going to define a very important concept that is called the frequency density. That is the quotient between the frequency and the width. This concept is key because it both allows us to compare data that comes from classes with different width, so we must define this, and then it also will be the height of the bar when the width of the classes are not the same. So let's take a look at another example for you to see here. Imagine that we are given this table. This table shows masses of children from 40 up to 50 not included, and from 50 up to 70. Again, there's no gap and there's no evidence of rounding here, so this is actual classes. We don't need to do anything else. But observe this. We have that the first class has a width of 10 because this is from 40 up to 50, so it's 10 kilograms there. But this one is from 50 up to 70, so it's actually 20 kilos there. That means that we cannot draw a histogram, as we are told to do there, just by looking at the frequency, because the frequency may mislead us. You see here, you can see that the class of 50 to 70 has more frequency. But the question is, does it have more frequency because there are more children actually there, or is it because the class is wider? Because clearly, as the class is wider, it makes sense that there are more children within it. So how do we compare them? Well, we compare them by calculating the frequency density. The frequency density is, remember, frequency over amplitude. The amplitude of the first class is 10, so the frequency density for the first category would be just 4, because 40 over 10 is 4. And for the second one, as the amplitude is 20, 60 over 20 will give you 3. That means that the first class actually has more a higher frequency density than the second one, so the bar that we're going to draw is going to be higher. It's going to look something like this. We're going to have, again, we're going to continue the excess because here we have a lot of data that we don't need to show. So Here we have 40 up to 70. We are going to omit all the values of the kilograms that are less than 40. And then the height of the highest bar is going to be at 4. It's going to be at 4 because the frequency density is 4. While for the second one, observe that it's wider because it goes from 50 up to 70. The height is going to be 3. So there we have the histogram shown for us. The next thing that we're going to see, and this is kind of like the end of how we're going to work with histograms for A levels, is that we can actually make some estimations of frequencies from the histogram. Why is that? Because the area relates to the frequency. So let's take a look at this. We're going to see if we can estimate the number of children that have masses between 45 and 63 kilograms. And this is going to be quite easy. Why is that? Because what we're going to see is we can try to find the area of this graph between 45 and 63 in the kilogram. And thankfully, these are just rectangles, so we know how to deal with those. Let's consider over here, we're going to draw a line around here. It would be this line here. Let me see if I can draw it there. And we're going to find this area that we have here. This is starting from 45, and so it's going to be this is a rectangle, so the width is just 5, and then we're going to multiply it times the height that is 4. That will give us 20, and then we're going to add this other. We're going to look up to 63. That will be around here. We don't need to make the actual drawing because this is just going to be a numerical analysis, but just for you to see what we're doing here is we are adding these two areas. Sorry about this, that my pencil is not helping me here. There we have it. So we're going to add this area here. That is going to be the base. Here is going to be 13. And then we're going to multiply this times 3, right? Because it's just, we're calculating the area, because remember, as we said earlier, the area relates to the frequency. So in this case, we can just take a look at the operations. It will be 5 times 4 from this yellow area that we marked earlier, and then this green area, that will be 13 times 3. We sum these up and we get 59 students. So we can make an estimation. It's just that, an estimation is not certain, but it's the best we can do with this diagram. 59 students that have a mass between 45 and 63 kilograms. So this is like everything that we can do with histograms. We can show data and we can make estimations. And remember two very important things. Thing number one is that if the classes have not equal width, this is something that will almost every time is going to happen with the A levels. The classes are not going to be the same width. So we must use frequency density. And then the other very important thing is that you must draw everything to scale. You must write the labels. Observe that here we have the mass here and the units, and here we have frequency density. And remember that if necessary, we can Cortina the excess so that we don't need to use, we don't need to fill unused space with things that we don't care about. So these are histograms for A levels.